Lesson 13.3, Task 5. Derive the formula for the sum of a finite geometric series. Just as a finite arithmetic series has a sum, the sum of a finite geometric series can be determined and a formula can be derived to find the sum. In the previous lesson, the formula of the sum of a finite arithmetic series was derived by carefully pairing terms when adding a general arithmetic series to itself. To derive the formula for the sum of a finite geometric series, a similar approach is used. Alright, so vocabulary. A geometric series is the sum of the terms of a geometric sequence. So it says, let S of n be the sum of the first n terms of a geometric sequence. Alright, so we have the first term, and then we have the first term times the common ratio, and then we have the first term times the common ratio squared, which is the common ratio times the common ratio again. And we go through that same pattern until we get to the first term times r to the n minus 1. So this is just a mathematical way to say first term times common ratio again, times again and again and again. Alright, so multiply S sub n by r, the common ratio of the sequence, to obtain an expression for r times S of n. Alright, so if we do that, we get a similar expression here. So r times S of n is going to be your first term times r, which is just slightly different than the one up here. And then a sub 1 is r squared. So again, just times the common ratio one time, which is what this means if we multiply the whole thing by r, the common ratio. Alright, so it says, why is the exponent of the last term in r, S of n, just a variable n? Alright, so that's just properties of exponents. And if we have alright, so if we have the r and then times the r to the n minus 1, the 1 and the negative 1 will just cancel out. So it's just going to be properties of exponents. So using the laws of exponents, r times a sub 1 times r to the n minus 1 equals this. Okay, so remember, properties of exponents here. Let's see if I can do this real quick. Well, my pen's not working. Alright, so remember this is r to the first power. And then if I put my r's same base, I add exponents and a first power and an n minus 1 power. The 1 and the negative 1 cancel and leave just the n. So my pen's not working, but that's why that works the way it is. Alright, and it shows it right here, r to the first plus n minus 1, and that gives you the a sub 1 times r to the n power. And that was just asking why this last term had n instead of n minus 1. And it's basically because we started by multiplying this one by r, and we did not, the first one. Alright, so now it says subtract r of S of n from S of n. Alright, so we're going to subtract this whole row from what's above it. And when we do that, we get this down here below. And you can see that it's plus dot dot dot, and then it comes down here. And it's because there's no specific ending place for this. So that's why they do it just in this notation. Alright, so it says, why is there a subtraction symbol preceding the last term? Alright, so we're subtracting each one of these from the one above it. Because the last term doesn't have anything above it to subtract, then that one would have to be a subtraction sign there. Alright, so it says simplify the expression for S of n minus r of S of n. So if we do that, we can factor out the S of n on the left side. So if we use distributive property, we're going to pull out the S of n, and that leaves a placeholder of 1 and then minus r. So you can see right here, they have pulled out the S of n, factored it out, and that's just using distributive property. and left 1 minus r. And they're going to do the same thing on the right side, except they're factoring out the a sub 1 because that's what they have in common. So pull out the a sub 1. Again, you need a placeholder, so 1 minus r to the n power here. All right, and then if I divide both sides, if I want to solve for s of n, I divide both sides by the 1 minus r, and that gives me this expression here. So this is the expression for a geometric series. Now, the good thing is you don't have to be able to know or memorize that formula. Here's the EOC math reference sheet, and you can see it gives you the arithmetic sequence, the geometric sequence, and the finite geometric series, which is what we're looking at right now. This is on your formula sheet. So you will see this on the EOC, but the formulas will be provided. So it's more important to know how to use the formula than to have it memorized or be able to derive it like we are doing right now. All right, so formula, this is important. I'd write it down and make sure you know it and make sure you know how to use it. All right, so what properties justify the final two steps of the derivation? The statement s of n times 1 minus r equals a sub 1 of 1 minus r to the n power is justified by the... All right, so that's justified here by the distributive property. All right, and the statement here is this one is justified by division because we divided both sides by 1 minus r. So that one should be division property of equality. Just says if you divide on one side, you have to do the same thing on the other side. All right, so the formula of the sum of a finite geometric series is s of n, s sub n equals first term times 1 minus r to the n power over 1 minus r. So it says explain the formula to find the sum of a geometric series. What key values of the series are needed to use the formula? All right, so we need the first term, we need r, which is the common ratio, and we need n, which is the number of terms. So we need the common ratio, the first term, and the number of terms. All right, that's all for task 5. If you have any questions, please let me know. Lesson 13.3, task 6. Calculate the sum of a finite geometric series. The formula that was just derived can be used for a finite geometric series when any number of terms, but it is particularly useful when there is a large number of terms or when the terms themselves are large. Consider the geometric sequence 4, 12, 36, 108, ... How much less is the sum of the first 8 terms of this sequence than the sum of the first 12 terms of the sequence? All right, so the series formed by the first 8 terms of the first 12 terms of the geometric sequence are both finite, so their sums can be found using the formula. All right, so this is the formula we found in the last task. It's the one I showed you that's also on the math reference sheet of the EOC, so this is an important formula to make sure that you know how to use it. All right, so what do we need for this formula? We need the first term, we need the common ratio, and the number of terms. So if we look here, the first term is 4, and if we're looking for the sum of the first 8, that means n would be 8. So all we have to do is find r, the common ratio. So if we do 12 divided by 4, that's 3. 36 divided by 12 is 3. 108 divided by 36 is 3. So we know our r is 3. So a is 4, r is 3, n is 8 for the first one, and then we're going to do the same thing again and do it with 12 so that we can see how much less the first 8 terms are than the first 12. Okay, so we're basically going to subtract. All right, so it says, can the fraction expression in the formula ever be negative? All right, so it can be negative, but when is it going to be negative? So it's going to be negative when r is less than -1 and n is odd, or it's going to be negative when r is less than 1, r is less than -1 and n is even. All right, so if this one's going to be negative and that's odd, that would become positive, and that would be positive as well, so that would not work. So this one is going to be the correct one. And the reason is when r is less than -1 and n is even, then that's going to make your numerator one sign and your denominator the opposite sign. So let's see what it says here. When r is less than -1 and n is even, the value of the numerator is negative, while the value of the denominator is positive. So when they have opposite signs, that's going to produce negative answer. All right, so determine the sum of the first 8 terms. So we already determined the first term is 4, and the common ratio is 3. And for 8 terms, we're going to use n equals 8. So we know these 3 numbers here. We're just going to plug it into the formula. All right, so if you use your calculator, I want to show you, you have to be careful. You do have to make sure you enter this correctly in your calculator or it will not give you the right answer. So if I type in 4 and then times, and I'm going to have 1 minus 3 to the 8th power, and I'm going to close my parentheses, and I'm going to divide. Then I have to divide by 1 minus 3, but this has to be in parentheses as well. So I have to do 1 minus 3 and close my parentheses. All right, and that's going to give us the 13,120 that we want. Now look what happens if you don't use the parentheses. You're going to have everything correct except you haven't told your calculator the order of operations to use. You haven't told it to do the top and bottom separate. So if you just put 1 minus 3 here, it's going to give you a completely different answer that is very wrong. So make sure you do not do this. Make sure when you're entering in your calculator that you are putting this in parentheses. The top will be in parentheses and the bottom will also be in parentheses. Okay? All right, so the first term and the common ratio are 4 and 3 again because we're using the same series, and now we're going to use the 12th term. All right, so why is only the value of n different? Because we're using the same series like we talked about. So since the same sequence is being discussed, the first term and the common ratio will be the same. All right, so using these values in the formula, okay, again, use your calculator. Make sure you use parentheses correctly. You're going to get the first 12 terms. The sum of the first 12 terms is 1,049,760. Oh, no, sorry, that's the difference. This was 1,062,880 was for the 12th term. But then we have to do the 12th minus the 8th, because if you remember from the very beginning, that's what the question said. The question said, how much less is the sum of the first 8 terms than the first 12 terms? So always go back to make sure that you're answering the question. So the difference would be 1,049,760. All right, so since that's such a large number, that's why they're saying that the formula is the best way. So the sum of the first 8 terms is that much less than the sum of the first 12 terms. All right, finding the sum of the 2 series and subtracting them is not the only way to determine the answer of the question. What alternate solution could be used? All right, so the alternate solution would be take this sequence, multiply by 3, find your first 12 terms, then add up the first 8, then add up the first 12 and find the difference. And that would be another way to do it. But then you have to be very careful to make sure all your numbers are correct as well. So the formula is a little quicker and easier. But again, there is an alternate method. All right, that's all for task 6. If you have any questions, let me know.